Friday, everybody. Okay, so welcome. We're almost to the weekend. So today what we're going to do is we are going to talk about slopes of parallel and perpendicular lines in our notes. And then you're going to have an exit ticket posted that you need to do by the end of the day today. So remember so yesterday I let y'all have a catch-up day because it was a testing day at the high school. And then remember on Wednesday when we did the Make It Right activity and we discovered the slopes of parallel and perpendicular lines. So let's go over. You need to find your journal, your blue Algebra 1 journal for this 9 weeks. We have already put the slide in, and it should be Unit 4, Lesson 2. So let's make sure. I think I just linked to the right one. Yeah. So it should be this slide, Unit 4, Lesson 2. It's already in your journal. You just need to open it up, and this is what we're going to work off of today. So you are going to need to get some scratch paper. So you're going to have to work some of these problems on your scratch paper, and then you'll upload your picture at the bottom. I'm going to work them on my iPad so I can write directly on the screen. But when you can't write on here to solve, you need to work on scratch paper. So the first thing let's do is let's take a quick review of slopes. So let's remember that positive slopes are increasing. So that would be a slope that looks like something like this. Negative slopes, on the other hand, are slopes that are decreasing. Now, slopes of 0, so think about this line right here is a flat line. It has no steepness to it, okay? Now, this line, vertical lines, are always undefined slopes. So the way I keep 0 and undefined slopes straight is I think about roof lines. I have seen a roof that has a steepness, a pitch like this, and I've seen roofs that have steepness like this. And in fact, if you put these together, you might see a little housetop forming here. I have seen flat roofs on buildings too. Our school actually has a flat roof on it. And that roof, if I was going to walk on that roof, would have 0 steepness to it, no steepness. So I can define that. However, I have never, ever seen a roof that's vertical, straight up and down like this. That doesn't even make sense to me as a roof. That's called a wall. I can't walk on a wall, so therefore I can't define the steepness of this line here. So it's undefined. So that's how I think of it. I've never seen a roof like that that's undefined. I have seen a flat roof, but it has no steepness. That's 0. Okay, so I'm going to move on over to my iPad so that we can work through some of these together. So here we go. Oops, well, that's not what I wanted to do. I want to do that. Okay, so since we just discovered on Wednesday that parallel lines have exactly the same slope, well, now if we're given equations of 2 different lines, we can determine whether or not they're parallel. So that's what we want to do. Are these examples 1 and 2, are they parallel lines? So in order to discover the slope of a line, remember, it needs to be in the form y equals mx plus b. Because then all I have to do is look at what's sitting in front of x, and that's my slope. So for example, let's start with number 2. I'm looking over here and I'm like, oh, the number in front of x is 10. Because look, I'm seeing that y on both of these is by itself on one side. These are solved for y. The number in front of my second one is negative 10. So when I have a slope that's 10 and then another slope that's negative 10, are those exactly the same? No, one's positive and one's negative. So these are not parallel lines. That's our answer. We've determined those lines cannot be parallel because they're not exactly the same slope. Well, let's look over now at example 1. Okay, 9x minus 3y is equal to negative 81. 12x minus 4y equals 60. There's my 2 equations. However, I noticed y is not by himself on one side on either one of these. So this is where your scratch paper is going to come in. And over here for number 1, you could write your slopes, and then just in that same text box, you can write parallel or not parallel. So I'm going to write the first one, and then I'm going to write my second equation here. So we actually have to solve both of these for y before we can determine what their slopes are. So I'm going to draw my lines. So let's start with the first one here, 9x minus 3y. So remember, if I want the y term by itself, I have to start by subtracting the x term. Make sure you write the 9 and the x, because 9x minus 9x's is now 0. So I'm left with negative 3y equals, now the terms over here on the right side are not like terms, so you just need to write them down. It doesn't really matter what order you write them in, as long as you remember to take their signs with them. So now the next step is to get y by itself. So I have to divide by whatever number is in front of y. It happens to be negative 3, not positive 3, it's negative. So make sure you divide by negative. So y equals, well, negative 9 divided by negative 3 is just now positive 3. Negative 81 divided by negative 3. So that's a negative divided by a negative. I know it's going to be a positive. 81 divided by 3 is what? Guys, I'm drawing a blank, y'all. I'm going to tell you, I'm not good with arithmetic in my brain. So don't be upset if you're not either. Don't think you have to do everything in your brain. I'm going to have to minimize this to get my calculator to pull up. So we had 81 divided by 3. It's like, 27. That's what I was thinking, but I didn't want to say it and be wrong. So this is 27. So I did all of that so that I could determine what number would be sitting in front of x. So the slope of this line is 3. Okay, so now I got to come over here to my other one and do the same thing. So I'm going to start by moving my x term. Got to move it over. So those cancel out, and I'm left with negative 4y equals negative 12x, and 60 is positive, so I'm going to put plus 60. Okay, so now I look and I say, well, what's sitting in front of y? It's negative 4. So that's what I'm going to divide everything by, whatever's sitting in front of y. So negative 4 divided by negative 4 is just y. Negative 12 divided by negative 4. Well, negative divided by negative is a positive. 12 divided by 4 is 3. So that's 3x. Now 60 divided by negative 4. That's a positive divided by a negative. It's going to be negative. And I know 60 divided by 4 is 15. So my slope of this line is 3, because that's the number in front of x. So yes, these are parallel, because I have 3 and 3. Those are the exact same slopes. So therefore, they're parallel lines. So that's how you determine if you're given equations if they're parallel or not. Okay, so what if we've been given some lines and they say, we'll determine if they're perpendicular? Well, you remember from Wednesday that perpendicular lines have to have opposite signs on their slopes. So this means opposite signs. One has to be positive and one has to be negative. And reciprocal, you can remember that's when you flip the fraction. So we have to discover our slopes here. So let's start with example 2 again, because look, because it's already in the form y equals mx plus b. So then all you have to do is look and find what number is sitting in front of x. Well, for this one, it's negative 5. So I have a slope of negative 5. For this one, I see I have a slope of 1 over 5. So I'm noticing that this one right here is negative. I'm noting this one is positive slope. So that's good. That's what I need. 1 negative, 1 positive. Now we have to determine, are the fractions flipped? Well, this is 1 over 5, but this is just 5 over on this side. But let's make him a fraction. How do I make 5 a fraction? Well, I put a 1 under it. So look, 5 over 1, 1 over 5. Those are flipped. So yes, these are perpendicular lines. Their signs are opposite. One's negative, one's positive, and those fractions are flipped. That's what makes them perpendicular. So for example 1 over here, however, though, these equations are not solved for y. So I've got to solve them for y first before we can look at them and tell the number and sitting in front of x. I can't just look right now and say, oh, my slope is negative 2 on this second one over here, because that's not true. It's not solved for y. It's not in the form y equals mx plus b. So let's draw our line. Let's solve the first one. So I want y by itself, so I'm going to end up subtracting this x term because it's positive right now. So x minus x is 0. And I'm left with a y. And then I'm just going to write down these terms. And again, it doesn't matter which order you write them in. I'm going to put the negative x term on the end. So now y is by itself, so I can look and say, well, what's sitting in front of x over here? It's a negative. What's that number that's really in front of x? He's sneaky, invisible, 1. So my slope of this one is -1. So I'm going to keep that in mind. Okay, so let's come over to the other side now and let's solve this one. So I have a negative 2x term over here. So the opposite of that would be if I added 2 x's. So -2 plus 2, gone. So 2y equals 10 plus 2x. Okay, so now I am going to divide by whatever number is in front of y. It happens to be 2. Okay, so 2 divided by 2 becomes 1y. Excellent. 10 divided by 2 is 5. And then 2 divided by 2 is just 1x. So my slope of this line is 1. Now, is -1 and 1 reciprocals? Well, this one is definitely negative, so that's good. This slope over here is positive, so that's good. But let's think about this. How do I make these fractions? Well, remember, you can put a 1 under anything, and if you do that, it's a fraction. So now if I took these numbers, is it flipping the fraction? It is. It's because 1 over 1 flipped is still 1 over 1. So yes, these are perpendicular. Whoops, forgot my R. I'm abbreviating perpendicular because it's a really long word. Perpendicular lines. Okay, so I want to look at number 3, example 3 with you, but I want you to do example 4 on your own. Make sure you have that completed because remember, your journal grade is a major grade. Okay, so I'm going to leave my iPad now because number 3, what we're going to do with it is these are funny looking equations, right? So for these, let's graph them in Desmos first. Let's see what we get here. So I'm going to come over here and I'm going to go to my Desmos. So the first one that I need to graph is, come down here to my notes on the second one, x equals 8. So here I go, x equals 8. Where's my line? Let me turn this on projector mode so you can see it. There it is right there. Oh, that is a vertical line. We just talked about those slopes. What's my other one I need to graph? Y equals 2. I want you guys to see the pictures of these. Oh, there it is right there. So that's a horizontal line. So I'm looking at these, and so these, we are trying to decide if these are perpendicular lines. Well, what is it? Does it look like they're perpendicular? Does it look like they're forming and making a 90-degree angle? Yeah, it sure does. It looks like they're exactly perpendicular, and they are, because this is a horizontal line and this is a vertical line. So that is the definition of perpendicular. So when you see something like that, the slope of a vertical line, so this one was vertical, remember, is undefined. Straight up and down line, it's undefined. Think of the roof thing. This one was a horizontal line, and the slope of a horizontal line, your slope is 0. So when you have a 0 and an undefined slope, and our picture looked like this, one line was going vertical and one was horizontal. Those are perpendicular lines. So there's a little thing you can remember to help you with this. It's called HOI and then VUX. Okay, so what it means is if you have a horizontal, let me see if I can go up, horizontal line, it has and this stands for 0. It has a slope of 0, and it's a y equals equation. For instance, this one, y equals 2, just a number. That's a horizontal line with a slope of 0, and it's a y equals equation. If you have a vertical line, that's an undefined slope. And it's an x equals equation. For instance, this one, x equals 8. That was a vertical line, it was undefined, and it was an x equals equation. So that the word HOI, VUX might help you remember slopes as well. Horizontal lines have a slope of 0, VUX, vertical lines have an undefined slope. So that might help you too. Okay, so number 4 is already solved for y. So all you need to do is look at the numbers in front of x and decide, are those lines perpendicular? So our answer for number 3 actually was yes. These are perpendicular. They are indeed. So look at number 4 now and see if you can do that one on your own. And then you're going to go back to Canvas. There's an exit ticket for today. So make sure you go back to Canvas and complete the exit ticket because I will take a grade on that.